My compatriot is Kevin Harwell. We're developers on the Asterisk team. And we're going to talk about the performance updates over the past year for Chan PJ SIP. Actually, we've got more people than I thought we were going to have in this room. I figured, yeah, it's going to be kind of a dry talk. The audience wasn't going to be all that big. And I will promise you that it's not going to be as entertaining as Evan's was. So I'm sorry about that right now. Let's get started. Is this going to work? It is, yes. OK. So we're going to talk about the challenges of just measuring and reporting on performance. I'm going to talk about the improvements that we've done over the past year and then turn it over to Kevin. Kevin's going to actually show you the results from the performance testing that we did. All right, Kevin, you want to do the slide thingies? So one of the big challenges we have with performance is defining what performance means and identifying how we're going to measure it. There's a good number of people in this room. If I went around and asked each one of you to tell me what you think performance means, I'd get as many answers as there are people in the room. And that's because everybody runs Asterisk in a different environment. They're on different hardware. They have different user profiles. They have different network environments. Even if you're all running FreePBX, say, a fairly consistent environment and layer above Asterisk, you'd still all have different user profiles and different environments. So there really isn't a good definition of what performance is. In the end, the way we are going to present our results is in terms of CPU, memory, and to some extent disk I/O, although we actually don't even show that on our slides because even that is highly variable. So that's the only way we can do it, where we can present a common framework. If we said, oh yeah, we were able to do 100 calls per second, well, what's a call? And in what environment? And is Asterisk handling the media, or is RTP engine handling the media? And is there a proxy in front of it? It doesn't mean anything. The other challenge we have with performance is that about half of the performance-related enhancements that we did to Asterisk this past year came from community members. And those community members are also in different environments, have different goals, have different user profiles. So there's kind of like a lot of shotgun approach to dealing with performance. Somebody's really interested in one area, so you see improvement there, but they're not really interested in something way over here. And somebody else has got something, way on that side that is really their pain point. So let's go to the next slide. So where do the improvements come from? Yeah, about half of them, I would say, come from the community, and the other half come from the Asterisk team at Digium Sangoma. We really like the ones that come from the community because they're based on real-life usage. The Asterisk team is a fairly small team, and we don't actually run Asterisk ourselves. Now, Digium Sangoma obviously does. Our own PBXs run Asterisk, and we actually learn from those. But the core set of developers, we don't run it. So the best feedback we get is from the community. And somebody said, we're really having a problem with contacts, or we're having a problem with inbound registrations, or we're having a problem with voicemail, or that's what we really like, and we like the contributions we get from that feedback. Even if you don't contribute, you should be looking at the changes file when you go from one version of Asterisk to another, because we generally try to highlight the performance improvements that we make there. We don't always, and as you'll see in one of the upcoming slides, There are performance improvements that happen because of, or as a byproduct of functional changes that people submit. And the performance improvement part kind of gets lost in the fine print. So keep an eye on the changes file if you are interested in performance, and you should always be interested in performance. Look at the changes file from release to release to understand what the impact is going to be. And if, this is kind of a plea to the community, if you have performance issues and you can make a good, replicatable case, create issues on our issue tracker, because we want to see those. We're very rarely going to experience those things ourselves, so having that information from you guys is very, very important. Yep. So let's see, I have to count these now. 1, 2, 3, 4, 5. Yeah, okay, so there's about 35. These are the improvements that I was able to take out of the commit log for the past year. I guess there's about 35 of them. But these are only the ones that I could identify from that one line, and you guys probably can't even read that, that I could identify from that one line that were directly related to performance. For every one of those that's up there, there's probably another 5 performance improvements that happened as a byproduct of some other functional change that just wasn't obvious. And every release that we do has got some of those performance changes in them. And let's see, we've been on a release schedule where we try to do, where's Matt? Matt Frederickson, did you leave? Oh, there you are. What's our minor release target? Like every 2 months or so, we try to do a minor release?
6 to 8 weeks.
Every 6 to 8 weeks, okay. We try to do a minor, yeah, but we try to do a minor release. So you can be fairly confident that there's going to be a performance improvement somewhere in Asterisk in every one of those releases. Yep. So the key improvements for the last year really fall into four areas. During last Astricon, there's usually one of the development team, and it's usually the same person, who stays back in Huntsville. We have to keep things going. Customers call in with issues, things have to happen. Last year, Richard Mudgett, who is, I would say, our most technically competent person on the team, spent the time while the rest of us were here, he spent the time working on call detail records. Call detail records have been a pain from a performance perspective for a long time because it takes a lot of resources to produce a call detail record. And sometimes you think, well, you're just writing one record out to a CSV file or to a database. But when you think about it, constructing a call detail record is a fairly complex process. If you've got a normal 2-party call, Alice calls Bob, they talk for 5 minutes, Bob hangs up, not all that complex. But what happens if Bob transfers the call to Charlie? Or it goes to voicemail, or there's call forwarding in effect. When you get that complexity in the call, it gets more difficult to determine who the 2 parties in the call were and when the call actually starts and ends. And it was taking a very long time and a lot of resources to correlate all that data and then get it written out to either the file system or to a database. Now, you could also say, so what? I mean, it's a call detail record. Do you really care how long it takes to get written out to disk? Let me answer that with a question. How many of you have access to an unlimited free pool of CPU, memory, and disk? Nobody, right? So those resources that it takes to process a call detail record has to come from somewhere. Where does it come from? It comes from the same pool that you're actually processing calls with. So improving the amount of resource or improving the Lowering the amount of resources it takes to process a call detail record actually gives you back resources that you can use for real call processing. Stasis. How many of you know what Stasis is? Yeah, a couple of you do. Stasis is our internal message bus. Why it's called Stasis, every one of you should walk up to Matt Jordan and say, why is your message bus called Stasis? Because the last thing I would want to do is put a message that's important into stasis. That means it's basically going to sit there and do nothing. So ask Matt Jordan that. Stasis, the message bus, if you're familiar with message buses, you want them to be as fast and lightweight as possible. Their job is to take a message in and deliver it to those people who are interested in it. There's a secondary function that we have in Stasis where we actually cache those messages for later use. Okay, later use. Why would you want to use a message that says Alice answered a call later? As it turns out, somebody did want to use those messages, and that is app voicemail. Okay, app voicemail. App voicemail has a feature where it can poll the back-end store for changes. If you're actually making changes to the file system or IMAP or your ODBC voicemail store from outside of Asterisk. How many of you use that feature? Anybody use the polling feature of app voicemail? Good. You should never use that feature. Somebody decided that having app voicemail know which mailboxes to poll based on who was actually subscribed to them was a good idea. At the time, they thought, well, we don't want to poll all mailboxes. We only want to poll the ones that somebody is actually interested in. Now, why would you have a mailbox that nobody was interested in? I don't know. But that's what they did. Then they thought, well, okay, how do I know who's interested in the mailbox? Okay, they can listen to stasis messages that result from a phone or a client doing a subscribe on a mailbox or an unsubscribe on a mailbox. Great. What happens when Asterisk first starts or you reload app voicemail? Now, basically, nobody's subscribed to anything. How do you know which mailboxes to start polling? So they thought, okay, I can use the Stasis cache to figure that out. Since Stasis caches every subscribe and unsubscribe, then app voicemail goes through the cache and reconstructs every subscription for the mailboxes. Now, that's kind of a long way of saying we were doing a whole lot of work for something that really did not result in any benefit. Because the bottom line is, it's far easier just to poll all the stupid mailboxes than it is to maintain a cache of every subscribe and unsubscribe message that came into the system for as long as Asterisk is running. And that's how long the cache stood around. So if you had Asterisk running for a week without restarting, your memory footprint just keeps going up and up and up, because every time a phone registers or re-registers, a subscribe and an unsubscribe pair gets cached. So this was one of those things where it was really hard to find and figure out why this was happening, but the fix was easy. We just don't cache them anymore. And Kevin will show you like a dramatic slide where things go like this and whatever. Qualify options process and inbound registrations. Those two are fairly tied together around contacts. The qualify options process is a fairly simple one where when a client, where a phone registers, we want to know that that phone is still there over time, or an ITSP or a peer or whatever. So at a configurable amount of time, we send a SIP options message to that device, and it responds with an OK. We now know that that device is real and they're working, and we record the amount of time it takes to do the round trip message. The issue that we have there is that it works really well if you've got 100 contacts. If you've got 5,000 contacts, it doesn't work so well, because most installations that have that many contacts are also storing all their configuration stuff in a back-end database. And in a lot of cases, that back-end database is not on the same machine that Asterisk actually is. Normally, they're in like a cluster environment where they've got multiple Asterisks and they're sharing the same set of configuration data. So the qualify process has to have like a background timer that's trying to figure out, constantly running, which endpoint do I have to send the options message to? But what happens if somebody actually changes the configuration? Now this phone, we don't want it to do options processing. Yeah, maybe it went away. In order to maintain that state, we have to constantly go out to the database, constantly go out to the database. And again, if you're not on the same machine that the database is on, that's a lot of overhead. It's also a lot of startup time, because when Asterisk starts, we have to go load all 5,000 of those contacts, bring them back into Asterisk, process them one at a time to see which ones we have to start options on. Then we have to start those timers. Then, as we're getting the data back, we got to write all that data back to the database again. So Josh Culp and some of the community members, Alexander, are you in here? Alexander Trud is another community member who has spent a lot of time helping us out with performance stuff. They spent a good amount of time basically rewriting the entire options process to get the number of database round trips down to a very small level. It's not perfect yet. We still have to do some more work, but that was a huge, huge increase. Inbound registrations are kind of the same way. When a phone registers, we create a dynamic contact, and we do an automatic options process just to make sure that it's still there and record the round trip time. That results in, for every registration we get, we have to go scan all of the AOR records in the database. So if you get 5,000, every time somebody registers, we got to go through all 5,000 to match that device against the configuration. Somehow we were doing that twice for every contact that registered. Not quite sure how, but that was another one where it's like, why did we do that? Accidentally, I can't imagine any of us would have done that on purpose, but finding that and getting rid of that second pass through all the AORs was actually another big performance improvement. Oh, that's it. Up to Kevin.
Yep. Okay. Now we will get to the part where we kind of talk about the results and also talk about, or hopefully show some of the data and graphs and stuff for that we've kind of gathered for some of the things. Not all of them, but some of them, as you'll see. So, yeah, George has kind of already gone over some of this, but I just want to say a little bit more about it, especially with regards to testing. I mean, performance testing, as he kind of mentioned, it can be tricky gathering results. It's made more difficult by a few factors, things like the size of the software. Asterisk is quite a large system, as everybody knows. The interaction between the software systems, subsystems, so Asterisk had many parts that talk to each other, different modules talk to each other in the core. Reliance on the external softwares. Asterisk uses various third-party libraries, so that's another factor. Also hardware dependencies and communications. So Asterisk heavily utilizes disk I/O and network I/O. And then George mentioned this as well, just the subjective environments. Asterisk just runs on an assortment of hardware and individualized configurations. So all these things and other stuff too, you just got to factor in and keep in mind while you're testing. Also, from a developer's perspective, again, George mentioned this, is just, what exactly are you testing and how are you going to test it and how do you narrow that scope? You got to keep that in mind. And luckily, Asterisk is very configurable, so we were able to, pare things down. Like, for instance, in the inbound registration, basically made it just so only the modules that were necessary to test that specific feature or topic in Asterisk. We could kind of compare more apples to apples that way and without having to worry about other stuff skewing the results. Also, another thing to kind of keep in mind, and again, George mentioned this as well, is just, what kind of test metrics are you focusing on? And that we had to keep that in mind for testing. What are we trying to test? What are we looking for? Are we testing memory, CPU, and that stuff? And that's what we did kind of focus on with CPU for the most part, and just trying to get the performance of that down a little bit. All right, so let's start with CDRs. Unfortunately, I don't really have any kind of graph or anything.
We should have made like the 30%, like fill the entire screen.
Yeah, giant 30%, yeah. This was worked on about a year ago, so some of that stuff, the testing and stuff is kind of lost, but I talked to Richard a little bit about it, and he said when his testing that he saw, based on the changes that were made, he saw roughly a 30% throughput increase in CDRs. And the changes were made to the core of the CDR module stuff, because basically with CDRs you have the core CDR module, and then you have like backends that you can configure CDRs to write to. So it should hopefully be an increase across for any of the CDR processing, any of the backends you might specifically be using.
And just remember that the 30% increase in throughput translates to less resources used for and more resources available for other things. It's not just, oh, we were able to write 30% more call detail records.
Yeah. All right, so let's see. Next up, we'll talk about the Stasis cache. Again, as mentioned, there are several changes that were made to the message bus, in particular to this Stasis cache. So here are the results of those improvements. George mentioned we'd be looking at a graph coming up, and this is it. So this shows the CPU and memory consumption of basically before and after the patches. So the red lines, that's the full cache lines. Those are the ones that show the state before the patches. So you can see here, you can see that both the memory, as the memory increases, the CPU increases as well. And but after the patches, those are the green lines. Those are the no cache lines. Here you can see the memory and the CPU kind of stabilize, and they across the board, and so that helps. That the patches you can see clearly helped or whatever as the time goes on. So that was a good thing.
Yeah, is that? Yes, it was. Well,
yeah.
This test was on 16, but the patches have gone into 13 as well.
This particular one, did it go? You
No.
put it in 13?
No, I'm sorry. Yes.
Okay, so I think it's in the main line. It's not in a release yet,
It's
right?
not. Yeah, it's not in a. Yeah, I'm sorry. It is in both the 13 and 16 branches, but the last releases of 13 and 16 don't have these yet. They'll be in 16.1 and 13.25, whatever the next release of 13 is.
Yeah, 13.24 maybe.
Yeah, I don't know. I can't remember. The 13, the numbers are just like once it went into double digits, I lost track. Yeah. When I was testing this, I was testing this on a 10-core i7 with 64 gig of memory. And even with that, this was 500,000 transactions. And transaction in this case was a register, subscribe, unsubscribe, unregister. I couldn't get it to run for more than maybe about an hour, hour and a half at that load. Before, the process used so much virtual memory that it kind of gave up. So after the change, it's like I stopped it after a day because I didn't want to let it tie up my machine anymore, and it just stayed perfectly flat. So. Yeah. Okay. See that exactly. Exactly.
Yeah. So that'll greatly help you. All right. Let's see. Moving on. So contacts. the core PJSIP resource in Asterisk. That's what contacts are down in kind of the core of the PJSIP resource. So it's kind of where the contact AOR and endpoint statuses as well as the SIP options get processed. So we'll talk a little bit about the versioning stuff here and where these specifically went in. So, so there's an effect. The effect was on multiple Asterisk PJSIP resources because of this. And you can see that prior to 1321, the contacts were a little bit problematic there. If you had configured a large number of static contacts, I think I did some testing with 3,000 plus contacts. The other way you could kind of duplicate this, one of the main problems was just have that many number of contacts dynamically register, and then you could do a reload. And essentially it would take multiple minutes. I think I just shut down Asterisk after 10 or 15 minutes because it just wasn't reloading. But whatever the time was, it was not acceptable. Yeah. And also these particular changes that affected the inbound registration and CPU also suffered because of this. So the contact rewrite greatly helped with all that. So, and as you can see in 1322, all these problems have gone away. So there were several patches that went into that, but again, the contact rewrite had the greatest effect. Now the reloads take, I would say, less than a second to process. Again, I tested 3,000 plus contacts. I want to say either for this or the inbound registration, I did up to 10,000, and it was still less than a second to process the contacts. I mean, there's other stuff loading depending on what you're doing with Asterisk, of course, but the actual loading now severely decreased the time did. So that's very good. So again, this also had an effect on the inbound registration. And that's what we'll get to next. So I don't know if a good number of you or who was here last year, the AstroCon, but there's a talk that was given that kind of demonstrated that inbound registrations performance was lacking in the PJSIP channel driver, especially kind of in general, but across, but also against and compared to CHAN SIP. There was a bit of a divergence there. So anyway, we started looking at that. We took the data of that seriously and did some investigation of our own. George kind of went over the details of some of the patches and whatnot, changes that went in to address some of those problems. But now we're going to take a look at basically a comparison of Res PJSIP now and CHAN SIP now and how it looks and some of our testing we went through. So let's start with just the test setup. So here's the system specs we used while we were testing. 2 cores and 2 threads. That essentially means 4 CPUs. The OS is going to view that as 4 CPUs. So in the charts coming up, we'll see like a CPU percentage on the chart, and that's essentially the average of the calculated averages of the data across those 4 CPUs. So that's where those numbers come from. Also, the hard drive, George kind of talked about this a little bit too. In registrations particularly, it's written to the ASTDB, so the type of hard drive you have can also have an effect.
Not can, will.
Yeah, will have an effect, yeah, exactly. So, so you keep that in mind when you're, building your systems or running tests and things like that. So, so it's important that we only loaded the modules, again, in order to make the test kind of an apples-to-apples comparison between the 2 drivers. So in CHAN SIP, for instance, I think had to load a few core modules and then just the CHAN SIP driver. And then in Res PJSIP, we had to load a few more. So anyway, here's a sample configuration for pjsip.conf. Those are the templates we used. And then we basically created 3,000, 4,000 endpoints, I think, out of that. And we loaded, 4,000, I got it up there. And then we would dynamically register those things. And we use a simple SIP scenario to drive the test over a local network. And this just basically sent the registration message to register to Asterisk. And we ran the test similar to last year. We ran it for about 5 minutes. So, all right, I'm going to probably start speeding up here in interest of time. So if it goes too fast, we'll hopefully get this data out somewhere. We got plenty of time. Huh? Yeah.
We got time.
That's true. So let's kind of go over quickly what we already know a little bit. These are some test results from 1321 prior to some of the patches going in.
Lower is better on these things, by the way.
Yeah, the lower the number, the lower the chart and the lower the number is better. So this reflects the results from the performance before the performance patches. So you can see that ResPJ SIP did consume more resources than ChanSIP. So I put also the CPU and the memory up there. We didn't really focus on memory as much, but put it up there because you'll see that some of the patches later on did actually affect memory consumption as well. Quickly, I'll mention at the 300, 350 mark, you don't see any stuff for ChanSIP. That's basically because ChanSIP stopped. It started having problems with retransmissions at that point, so you couldn't get any more data out of it. But I'll talk more about that in a second. Okay, real quick. 1321 ResPJ SIP used about 7 to 8% more CPU, as well as more memory for both channel drivers up to that, for ChanSIP up to the 350 mark. Both of them were able to had negligible retransmissions well below the 1% mark. I think, matter of fact, there's maybe in the 5-minute test, maybe getting like below 5 retransmissions or so. So this is kind of what the current 13 looks right now, the latest release 1323.0. So you can see the memory footprint really hasn't gone down much, but there has been a significant decrease in CPU for ResPJ SIP. As a matter of fact, it is below ChanSIP now, so that's excellent. And you'll see similar results in Asterisk 16.0. It did do some of those tests. I didn't put a chart up for it, but the same patches that are in 1323.0 are in 16.0 as well. So if you upgrade to that, you will see very similar results as well for the 16.0. So again, to reiterate, 1321, we saw that ResPJ SIP was probably 1 to 2% less now. And the memory stayed the same, and again, retransmissions run and test through that were about the same as before. So, so this is I wanted to put up stuff for what's going to be coming out for Asterisk 16.1. This is the current branch of Asterisk for 16.0, and this will be in the next release. So you can actually see now the memory has gone down significantly. There's been a patch that was put into 16 branch. It hasn't gone out yet, but it'll be out in the next release, that reduces the memory, and you can see that it also reduces the CPU even a little bit more. So actually, yeah, it uses now with the patch, it uses about 3% less CPU versus ChanSIP, and the memory dropped by 3 to 4 megabytes. And retransmissions, again, were really good. Very little retransmissions. So upgrade to Asterisk 16, and once 16.1 comes out, you'll see even more improvements versus ResPJ SIP versus ChanSIP, but also versus 13 branch. So, all right, let's go quickly back to the that data point I mentioned earlier about the one that we saw in inbound registration charts where there's no data for ChanSIP at the 350 registration mark. This is essentially where ChanSIP began to choke on retransmission, given the hardware in our testing. ChanSIP could handle 300 registrations per second, roughly, but you start going over that a little bit, and like I said, I tested at 350, and when it did, it just could not keep up. And you can see that it's right here, after about 3 minutes into the test, you're looking at like a 96% retransmission rate or around there. So ResPJ SIP, on the other hand, was able to easily handle that and a lot more. In fact, it was able to do, as you can see, 2,000 registrations per second with little retransmissions. And I even pushed it up to 2,500 registrations per second, and that only resulted in like a 1-2% retransmission rate. So it's very, very good.
So I would like to caution, though, on those numbers. Nobody should go back and say, oh, gee, I can run 2,500 registrations per second on Kevin's test box, which was, the Core i3 with, 8 gig of memory. The numbers are really there to show the comparison between ChanSIP and ChanPJ SIP. Kind of like I said earlier, it's almost impossible to be able to give anybody a guarantee of how many calls per second or transactions or registrations per second you can do in an environment. And we get asked that question all the time on the forums, on the mailing list. It's like, gee, I've got, this box. How many calls per second can I do? I mean, I don't know. Define what a call is. Are you doing the media? Are you not doing the media? How many conference calls do you have at that time? What's your disk I/O like? You just can't do it. So take the data as a starting point. How many of you do your own performance testing? Okay, good. Actually, that's more than I thought were going to raise their hands. Performance testing is really something you should do even if you're a reseller and you're not actually running Asterisk yourself. It's a good idea to do that set of testing, so at least you have the firsthand knowledge that you can then communicate to your customers or help guide your customers towards a valid hardware and software platform that will not have them yelling at you too much later on when you run into issues. Let's see, I was going to ask you another question, but I forgot what it was now. Feedback. We want feedback. As I said earlier, the only way we really know what to concentrate on from a performance perspective is by listening to you guys. So open issues on the issue tracker, when you have performance issues, and let us know. It's not a guarantee that we can fix it for you or fix it for you in 5 minutes. Unless you have a service contract with Digium Sangoma, then that'll be good. But at least it gets it into our queue. We are focusing on performance and stability over the next release cycle. So how many of you do software development for a living? Okay, some of you do. You know that generally you kind of go in cycles. You spend a good amount of time working on functionality, stuff that your users can see and put their hands on. And then you wind up having to take cycles, another development cycle where it's stuff that they don't see, but it's stuff that's really important, like performance and stability. So what we're trying to do with this development cycle is do more in the performance and stability areas. So that's kind of where we are, what we're going to try and focus on in the next, 6 months, a year. Questions? We love questions. Yeah.
Thank you very much. I think this is a question more of my colleague, Ray. I'm not sure if you hear. Oh, there you go. I think we moving from ChanSIP to PJSIP, and one issue which we see is we've got large number of endpoints, and what PJSIP wants to do is it actually wants to load all of them in the memory at the startup, and that causes a lot of issues. What's your feedback on that?
Are you using the real-time database backend or using configuration files?
MySQL at the back end.
Okay. There are a couple of things that you can do. Do you use the sorcery caching? Yes, you do. Okay. So tuning the sorcery cache will definitely help with that. And tuning caches is an art form. It's something that you have to try and tweak to find the right balance of keeping the things that you really need in memory and letting the things that you don't really need expire out. I don't really have any advice other than trying to spend some more time with the caches. What version of Asterisk are you on? 15.5. Okay, so we did make some caching improvements, a ways back in 13 that allow you to do, oh God, I forget the, thank you, full backend cache. Okay, all right, good. I would say keep doing it that. If you're really having issues even at that point, please open an issue on the issue tracker and let us know, or go to community.asterisk.org and post questions there, because that's kind of something we can work out.
Are you having trouble reloading or memory? What's the problem?
So the problem is the number of endpoints. If we have, say, 60,000 rows in the AORs, and
Is
the
it just take a long time to load, or?
No, it actually causes core kind of crashes, and if we drop it down to like 15,000, I think it's been perfectly stable. So it's just, we're not sure.
Okay.
All right, because I wasn't sure, because 15.5.
It's not the amount of traffic on the
What's
box,
the
it's just
version?
the amount of data in the store.
I don't know if some of these things went out. I'm not sure what version some of these particular patches even went in, like the contacts rewrite and stuff like that.
Yeah, I'm not sure about that.
I don't know what version of 15 those went in.
The other thing is what operating system you're running on. Okay, look at, are you using the ODBC connector to get to MySQL? Okay, look at the ODBC connector, because there have been issues in the ODBC interface layer between Asterisk and MySQL. You are much better off not using any packaged version of the connector, but getting the latest and compiling and install yourself.
And then enable connection pooling, right?
Yeah. Enable connection pooling.
Yeah.
Yeah, you want to make sure you enable connection pooling, because there was some contingencies there. Old versions of Unix ODBC did not properly support connection pooling internally, and we had to do our own implementation of it on top of it. And so there's a option in the, what is it, odbc.conf,
Yep.
where you enable a connection limit, I think it is called, that you set the number of connections in the connection pool and things like that. But it is contingent on a recent version of Unix ODBC, which many distributions, even new distributions, do not package.
Exactly. Specifically, if you're on CentOS 7, CentOS 7 is behind on a number of packages. Unix ODBC is one, libsrtp is the other, that it's also behind on, just as a side note. So some of those things you are, if you're on distributions that are a little bit further behind, you are better off compiling from source for those things.
David?
David?
Question about you said talking about CDRs and using resources on the box. Is that at the end of the call, or is that throughout the call that Asterisk has to keep track of it? And does that get better on the box if the module is completely disabled? Say you don't use Asterisk because you're using your own CDRs.
Yeah, it is at the end of the call, but so it doesn't necessarily affect the call that actually generated the CDR. But while it's processing the CDR, of course, you're also trying to process other calls. I'm sorry, David, what was the other part of the question?
No, I blanked out as well.
One thing, sorry. Is it all right if I talk, George?
Yeah, go ahead.
All right, so one thing with regard to your question, if you're not using CDRs, it is better to disable it.
Yes.
To disable the CDRs than just let them go, because there will be a performance impact on your system, and it is a noticeable performance impact.
Yeah,
So
disable the modules.
Yeah, for example, our best practice recommendations we have to people trying to build high-performance Astra systems. One of them is don't use CDRs, use CEL, right? If you need to keep track of calls, use CEL and have another system that's responsible for stitching together the CELs to turn them into a CDR record, right?
CEL is the channel event log, and there's almost no overhead in that because we're just basically writing events out to CSV or database or whatever.
Thank you.
Okay. We were just talking about disabling modules. There's another set of modules that are kind of stealth modules that pretty much everybody should disable unless you actually need them. And I know there's going to be a talk a little bit later about Homer. Well, we have two modules called reshep and respjsiphep. If they're enabled, they put hooks into things that cause a lot of things to slow down. You should use them if you need them, but if you don't use Homer, disable those modules, either don't build them or in your modules.conf file, do a no load on those. In newer versions of Asterisk, I think the samples do explicitly no load them. But you should take a look at those yourself because they will eat resources.
Okay, thank you to Kevin and George. I think that's all our time. We've got a half an hour, I'm assuming it's coffee break. So if you have more questions, find them out in the hall. And we'll see you guys back here in half an hour.
Yep. Thank you all.